Hello everybody and Assalamualaikum. Now Cikgu want to share about momentum. Before that, you have to know the principle of conservation of linear momentum. Alright, remember the principle of conservation of momentum? Okay, in isolated system, the total momentum must be conserved. Alright, mean in isolated system, the total momentum before collision must be equal to the total momentum after collision. So, for example, you have elastic collision. Okay, two objects collide and after collision, the object move with different velocity. This is characteristic of elastic collision. So you have M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. So you have two different velocity. In elastic collision, alright, after the collision, the object will move with same velocity. So you have M1 U1 plus M2 U2 equals to M1 plus M2. Okay, you have V, small v here. Okay, which show same velocity. Then you have explosion. In explosion, before collision, the object is at rest. Alright, but after collision, the object will move with different velocity. So you have 0 equals to M1 V1 plus M2 V2. Alright, this is actually for one dimension. How about collision or momentum in two dimension? Okay, for example, this question. A homemade rocket is moving at a speed of 45 meters per second. The rocket breaks into two pieces of equal mass which fly off with velocity v1 and v2. Alright, as figure above. Calculate the magnitude of v1 and v2. Neglect the effect of gravity. So, this is one example of collision in two dimensions. Alright. Okay, this is two-dimension collision or two-dimension momentum. So, from this diagram, alright, this is before collision, this is the situation before collision, and this is situation after collision. Alright, so, okay. So from the conservation of momentum, so you can solve this question. So from total conservation of momentum, total momentum initial equals to total final. Okay, but in this question you have two dimension. Can you see? Alright. Okay. Okay, before collision, you have object move to the right. Okay, but after collision, the object will split and move with different direction. Okay, this velocity can be resolved. Okay, can you see this is a vector? See vector v1. So v1 can be resolved to x component and y component. So this is v1x. Alright, and this one is v1y. Okay, and for this one also, for v2 also can be resolved Okay, v to x and v to y. Okay, okay, as you see the vector here. Alright, okay, when you sketch a vector, okay, you must start, okay, tail always into the center, okay, but the head is, the direction of it is outward from the center, from this point. Okay. Okay, so you can see resolving vector which x and y component. Okay, before collision you have x component. Okay, after collision you have x and y component. So what you have to do, you have to resolve the momentum. Okay, this is x component. Okay, so before collision the object is moved, so you can use this concept. Okay, m1 plus m2 equals to m1 v1 plus 2v2, right? Okay, since the rocket breaks into two pieces of equal mass, okay, let's the rocket have mass m initially, so m, then you have u, actually 45 meter per second, so you have u is 45, then the rocket split with equal mass, like m1. If before before split you have mass m, then after rocket split you have half. Okay, so v1 is, okay, since v1 is, since the angle is 60 degree. Okay, the v1 is v1 cos 60 degree plus, okay, m2 is half m, okay, v2 is cos 30. Okay, okay, so you can simplify, you cancel m. Before you cancel you have to factorize, okay, the equation. Okay, m half, alright, v1 cos 60 is 0.5, okay, 0.5 plus half km, okay, v2 cos 30 is 0.866. Okay, okay, and after that you can cancel out the m, so you get 45. Alright, so 0.5, 45, 0.25, okay, v1, right? Okay, plus, okay, this you can simplify, 0.866 divide 2, okay, which is 0.433, okay, b2. So you have to unknown here, then making v1 as subject. Okay, you can choose v1 or v2 as subject. So divide minus, right? Bring forward here the minus 4, 3, 3, V2. Okay. Okay, then get 0 to 5. Okay, 0.25. And this is first equation. Then, alright. Then we can continue. Okay. The problem still cannot solve, so you can continue using y component. Okay, so this is y component. Okay, y component. Can you see before collision? Okay, no y component here. Okay, before collision, but after collision you have y component, right? So before collision, no y component, so 0. After collision, you have m1, v1 plus m2, v2. Alright. Then substitute. Okay, up and v1. Okay, v1. v1 is here, v1y. Okay, v1 y component. So v1 sine 60. Okay, plus up. Okay, and v2. Okay, this is 30. Okay, remember downward must be negative, so put it negative v2 sine 30. Okay, then you can simplify. Okay, carry, move forward, and okay, v1 sine 60. Okay, equals to, okay, move here, so negative is no more negative, up, and so v2 sine 30. Okay, then you can cancel. Okay, v1 sine 60 is 0.866. Okay, then v2 sine 30 is 0.5. Okay, then you can make v1 as subject. Okay, 6. Okay, then you can see two equations here. Okay, equation 1, v1. Okay, 45 minus 0.433 v2 divide 0.25, and the second equation v1 equals to v2 0.5 divide with 0.866. Okay, the sign is important. Okay, then you can substitute ratio. Okay, 45 33 v2 divide 0.5 equals to v2 0.5 0.66, and you can calculate. Okay, you substitute mathematically. Okay, remember mathematics. So 0.66 45 minus 0.433 v2, and v2 0.5 0.25. Okay, alright, so you get 0.1 for v2 plus 0.375 v2 equals to 38.97. Okay, finally you get V2 is 77.9 meter per second. Alright? Okay, that's all. After that, after you find V2, so substitute to equation 2. Okay, because this is easier. So V2 is 77.9. Okay, 0.5 divided with 0.866, and you get V1 is 45 meter per second. Alright, so in conclusion, okay, to solve conservation of momentum, you must consider the negative and the suitable concept used. Alright? Okay. So thank you for listening. Enjoy learning physics. Thank you very much.